The equilibrium expression. When opposing processes occur at the same rate, a stable but dynamic state called equilibrium is established. The expression for the equilibrium constant, K, is a mathematical relationship that describes the equilibrium state associated with a chemical change. If you had a general chemical equation where capital A, B, C, and D represented chemicals, and lowercase a, B, C, and D represented stoichiometric coefficients, then the equilibrium expression K could be written as this. The concentration of C raised to its stoichiometric coefficient times the concentration of D raised to its stoichiometric coefficient divided by the concentration of A raised to its stoichiometric coefficient times the concentration of B raised to its stoichiometric coefficient. Or you can say products over reactants. All of these concentrations are the concentrations when the system is at equilibrium. If that chemical equation was reversed, the equilibrium constant would be inverted. When a chemical reaction is reversed, its equilibrium constant for the reversed reaction is the inverse of the original. So here we have the reversed equation's equilibrium constant. The inverse of the original equation equals the equilibrium constant of the reversed equation. If for some reason, if you need to multiply through the chemical equation by some number, like this, 2, so you're multiplying this chemical equation through by 2. When the balanced chemical equation for a reaction is multiplied by 2, the equilibrium expression for the new reaction is the original equilibrium expression raised to the second power. Thus, when you multiply the chemical equation through by 2, the original equilibrium expression, K, is squared. Then you get the new equilibrium expression for the chemical reaction that you multiplied through by 2. Here's another example where you multiply a chemical equation by a number, in this case 1/2. Let's see what happens with the equilibrium expression. So if you multiply a chemical equation through by 1/2, the new equilibrium expression is equal to the original equilibrium expression raised to the 1/2. All right, so we can summarize these conclusions about the equilibrium expression as follows. The equilibrium expression for a reaction is the reciprocal of that for the reaction written in reverse. When the balanced equation for a reaction is multiplied by a factor n, then the equilibrium expression for the new reaction is the original expression raised to the nth power. K values are customarily written without units, and I'm going to make this raised to the nth power. I believe that's better. This is an exponent here. All right, any questions?